Okay, the title of this lecture is Basics of Crime Research, Part 2. And here we're going to go over the social scientific method, and it's a basic introduction for sampulations of samples, populations, and how we go about this process of collecting data using the social scientific method, sometimes called the scientific method. But you see a little picture there, and that's basically the process. We're going to have something called a population, which is a group we wish to study. We're going to take a sample from that population. We're going to study it, and we're going to hope that it's representative of that population, and then we infer from the population, infer from the sample back to the population. So if you have a big group called a population, you take a subset or a portion of that. You can't study that whole population, so you study a small group of it called a sample, and you hope that that small group is representative of the whole population, and thus you study that small group and you infer from that small group called the sample of the population. That's an overview, and you'll see we're going to get into this in quite a bit of detail in this lecture. Okay, there are rules and assumptions for collecting data using the social scientific method, or it's called the scientific method, but actually, to be exact, since we're in the social sciences, we would call it the social scientific method, but the same rules apply in either instance. What you essentially do is you take a sample from a population and you sort of hope that the sample is representative of that population. Now, sampling is incredibly complex, and we're going to only get into the very basics of it. But just to give you a clue of how complex it is and how good they are, you'd actually have to get almost a doctorate in population studies to be able to do this. But here's how Gucci it gets, if you will. I like to say this is how Gucci it is, to mean how complex it is. Okay, using modern sampling techniques, they are able to accurately represent all U.S. voters. Think about how many U.S. voters there are. Certainly well into the millions. There's about 200 to 300,000 people in the U.S. Let's just pretend there's only 50 million people who are registered to vote. That's a large, huge group. And using sampling techniques, they're able to accurately represent all U.S. voters using a sample up from that group of only a couple thousand. In fact, so that's amazing if you think about it. They're so good at it, I don't know if you can remember back to when they used to call elections on election night on the news media. They'd use something called exit polls, and they were so accurate that they were able to to sort of predict what would happen. They call it calling the election in advance. So they would tell you who was going to win the election before the polls had even closed. And what happened was that people in the western part of the country, primarily California because it's such a huge, it's the biggest state in the union, but we would apply too. But so on the East Coast, the news media would be basically saying, okay, we can already predict who's going to win the presidential election. And the Congress is going to pass a law saying they couldn't do that, and the media didn't want to be regulated. So you'll notice now, currently, they won't call elections, tell you who's going to win until the polls have actually closed. Okay, we have to give you some definitions of what a population is and a sample is. The researcher actually defines the population. The researcher decides upon the group of people she wishes to study. Okay, this group is called a population. A more formal definition is a complete collection of measurements, objects, or individuals under study. But a more common sense one is think about the group of people you wish to study. Okay, that's what a population is, and it's defined by the researcher. Okay, now, the researcher cannot study a whole population. Think if you wanted to study the population of U.S. voters. Let's pretend it's 50 million people. There's no way that you could actually have the time to speak to all of those people. You wouldn't have the time, resources, nor money to speak to all of those people. So what you have to do is you have to study a portion or a subset of that sample, of that population, and that is called a sample. Okay.
So since you can't study a whole sample, the researcher defines the population she wishes to study. In this case, let's pretend it's U.S. voters. And this is an intellectual act. You, as the researcher, decide who it is you wish to study. What is going to be, if you have your research goals for your study, and then you decide, well, which population will allow me to answer those research goals, those research questions about my population. So you have to define a population. Okay. So if you were to ever do a student project, you as the student would decide on your own how to define the population you wish to study. And we'll complicate that in further slides. Okay, here you have a visual that hopefully gives you an idea of what a sample and what a population is. Okay, so you have a population. That's the group you want to study as a researcher. Almost always it's made up of people in the social sciences. But to give you an example of a population used in crime research. In the United States, we'd like to know how many people are victimized by crime. And so what the federal government does is it funds a study that studies the U.S. household population aged 12 and older. So that's a population. Okay. You can see how that's an intellectual act. You could define, if you think about it, the U.S. household population is not everybody in the United States. Some people don't live in houses. Some people live on the beach, for example. Some people live in prison. Some people live in what we call transient living situations, where they're always going from auntie to uncle's couch over and over and over like that. So they're not permanent members of the household population. Sometimes they would be missed. Okay. Almost always it's people, but you'll see in later slides it can be other things as well. But for right now, just think it's the group of people or the group that you wish to study. In most cases, it's people. Okay, now, the U.S. household population aged 12 and older, you couldn't possibly study that whole population. So what you have to do is study a portion of that population. Well, that's what a sample is. Okay, a sample is a portion or a subset of that population. It's taken from the population. We study that small sample, and then we say, well, we didn't speak, if you will, to everybody in that population, but we spoke to a portion of that population called a sample. And then we hope that the sample is representative of the population. Okay, so we study the sample and we infer from the sample back to the population. And there's always some error when we do this. Always. Okay, that's called sampling error. If you've seen polls, good polls that you see in the media, sometimes they don't give you this information, bad polls. They'll always, for example, they'll tell you what percentage of Americans support this candidate. And they should always give you plus or minus so many percentage points. That's essentially sampling error, to give you an idea. Okay, so whenever we sample, we don't speak to everybody in the population. You only speak to a portion or a subset of it. You don't have to be a rocket scientist to figure out, well, if I don't speak to everybody, then there's bound to be some error. Let me give you a smaller example. What if I had the population of just people in this class? Let's pretend there's 30 people in this class. And I wanted to say, well, hey, am I doing a good job as a teacher? But I only spoke to about 5 or 10 people. Okay, well, and then I said, well, those 5 or 10 people represent the population of 30 students. Well, you could see there'd be some error there. In fact, that's what happens all the time in teaching evaluations. And you'll see a little bit later, because we don't have random selection or a random sample in teaching evaluations, we can't accurately say they're descriptive of the population of all our students. However, sometimes even academics, my colleagues, don't understand this. Okay, so we have a population. That's the whole group of people you wish to study. You can't possibly study all of them. So you have something called a sample. You take a portion or a subset of that population, you sample them, and you say that sample is hopefully representative of the population. We're going to infer from the data taken from the sample to the population. But when we do that inferring, there's always some sampling error. There's always some error. And that comes from the fact that you don't speak to or study everybody in the population when you take a sample, because it's a smaller group, right? Okay, next. Okay, let me give you some definitions here. The population is made up of something called sampling elements. I'll give you, as you can see there, the next slide has a visual on this, so don't panic, we'll go over it again. But here's sort of definitions you can use. The population is made up of sampling elements. Okay, sampling elements are the exact thing the researcher wishes to study. Okay? Most of the time, they're made up of individual people, and the sampling elements are the exact unit of analysis. If you, when you make a study, your population is made of sampling elements. As you're going to see, we select sampling elements, and we select these sampling elements, and that's the exact unit of analysis. Most of the time they're people, but they can be anything. Example, when they're not people. Well, I gave you an example. One example of when they are people, if I wanted to study victims of crime, I studied the U.S. household population age 12 or older. I'm selecting individual people age 12 or older who live in houses or apartments. That would be the sampling elements. That would be individual people. Let me give you some examples of when they're not individual people. What if you wanted to study what kinds of drug treatment programs are most effective? You wouldn't study, so you're interested in how they structure their programs that actually treat drug addicts. Well, in that case, you would probably study individual drug treatment programs, not individual people, right? Same thing, maybe sex offender programs. What if you wanted to figure out what kinds of therapeutic programs are effective for sex offenders? Okay, you would not study individual sex offenders because you're not interested in that. What you're interested in is which programs as a group are more effective in sort of treating sex offenders. So in that case, you see how your sampling elements, if your study was about studying programs, you would study actual programs, not individual people. Maybe you were interested in studying individual prisons, something like that. Okay. So what we do is we select a number of sampling elements. Here's the process of sampling. We select a number of sampling elements from the population. We study them, and we hope that they are representative of the rest of the population. Remember, we infer from the sample to the population. But because we do not study everyone in the population, there is always some error when we infer, and that is what sampling error is called. So whenever we infer from a sample to a population, there's always going to be something called sampling error because we have not spoken to everyone in the population. Again, here's another visual definition, but I've just shown you here that the population is made up of sampling elements. Okay, that's the only real difference from the previous slides. I won't go over it ad nauseum, but we have a population. That's the group that we wish to study. It's made up of sampling elements. Typically it's people, but it doesn't always have to be people. For example, a former UH West Oahu professor who's now on another campus, he studies humpback whales. He's a psychologist who studies humpback whales. So he drives around in airplanes and he studies humpback whales. So his sampling elements, I'm not exactly sure of his studies, but I'm thinking that his sampling elements are either individual humpback whales, maybe pods, which are a group of whales. Okay. And then he obviously can't count all the humpback whales in the Hawaiian Islands, so he takes a sample or a subset or a portion of all the humpback whales, and he studies them, and he hopes that they're representative of the population of all humpback whales. Okay, so that's just another visual giving you the idea that the population is made up of sampling elements. Okay. When we infer from the population to the sample, it's called inferential statistics. Okay? So remember, when we study a sample from the population and then infer from the sample to the population, we hope that that sample is representative of the population. Okay? And inferential statistics is the fancy word, that's a fancy phrase for what happens when we take a sample from a population, we study it, and we refer back to the population. Okay? Inferential statistics is the basis of modern science. Okay? And inferential statistics require something called probability samples with random selection. Another way to think about this is, what these terms mean is that a probability sample is, think of it as a random sample. Okay? And I'll get into this. I'll give you a more fancy definition on the next slide. But probability samples, in order to use inferential statistics where we can measure this error, when we in order to measure sampling error, we have to have something called a probability sample, where sampling elements are randomly selected from the population. You can't purposely select people. So the common sense definition right now is to think of it, in order to use inferential statistics to infer from a population to a sample, you need a random sample. Okay, you may have heard of that term. Okay, let me give you a more precise definition of a probability sample. We know in advance the likelihood or the probability that a sampling element from the population will be selected into the sample. That's a fancy way of saying, for the purposes of this class, think you have a random sample. The important part of a probability sample is you have something called random selection. And that, when you have random selection, remember, you have a population made up of sampling elements, and you're going to select those to be into your sample. In that process, you must have random selection of sampling elements. What that means is that the researcher has no control over which elements are selected into the population. A perfect example of random selection is Keno or bingo. What is Keno or bingo? Think of, you have 49 balls in this big sort of, the way they would do it in the olden days is they had actual sort of ping pong balls in this wire hopper, and they would spin it, and then a ball would be randomly selected out of those 49 balls. Now the key there is that the person spinning that wire hopper has no control over which balls are going to be selected. That's random selection. So in order to have a probability sample, you require random selection. A non-probability sample is that the researcher does not know in advance the likelihood or the probability of a certain sampling element being selected from the population. Okay? So in order to use inferential statistics, we require a probability sample. By the way, almost all student projects will use a non-probability sample. So even though you see a lot of people doing senior projects around our campus, and they're using inferential statistics, but they don't have a random sample. And actually, by the rules of statistics, when you take the class, you'll find out that you actually cannot use the data from a non-random sample when you use inferential statistics. So chi-square, all of the things you might have heard of, t-tests, etc., require a random sample. Now, that's not necessarily a bad thing that students are out there doing those kinds of projects, because, you know, we're in school and we're just learning. Okay, so there's nothing wrong with that when you're learning the process. All right, matching populations, sampling frames, and sampling elements. Good probability samples depend on having a sampling frame that is representative of the population. This will make more sense when I tell you what a sampling frame is. We need to have a good match between our sampling frame and our population, okay, when we use inferential statistics. Now let me explain what a sampling frame is. Okay, a formal definition would be something along the line of this. It's a list that operationalizes our population, and it closely approximates all of the sampling elements in our population. When we do this, we've created a sampling frame. A more common sense definition is a sampling frame is the group from which I will pick people to be in my study. Okay, you have to have a list that approximates your population. That's called a sampling frame. And from that list is how you pick people to be in your study. Remember when I said there's a study that studies, there's a research project that studies, tries to figure out how many people in the United States are victimized by crime each year. Think about everybody in the United States. It's hard to come up with a list that would approximate every single person that lives in the United States, because everybody's hard to locate. So what they use as a sampling frame is the U.S. household population aged 12 and older. Now, that's not a perfect match, of everybody in the household population, but it's a pretty good match to, I'm sorry, the household population is not a perfect match to everybody in the United States, but it is a pretty good, that sampling frame encompasses most of the people in the United States. Okay, so that's an example of a real sampling frame. But a common sense definition is it's the list of people from which you will choose to be in a list of people that approximates your population, and you're going to choose from that list people to be in your sample. Okay. A good sample is dependent upon a good match between the sampling frame and the population. Okay. It is difficult to find a sampling frame for any sort of deviant population when you have deviant research questions, but don't throw the baby out with the bathwater. So, for example, I said we're trying to measure how many people are victimized of crimes. Those people aren't necessarily deviant, people who are victimized by crime. But it's difficult to find a sampling frame in certain instances when you think about crime. For example, I'll give you some examples in a later slide. Okay, but whenever you see a lot of crime studies don't have a very good sampling frame, but don't throw the baby out with the bathwater. So, for example, if I wanted to study hardcore drug addicts, notice how I define that as hardcore drug addicts. Perhaps I might study. It's hard. There's no list out there of all hardcore drug addicts, but maybe I might study people who are in treatment. That would be my sampling frame that would approximate my population, and I would choose, that would be the list, people who are in drug treatment. I would randomly select people from that list. So, I mean, it's not a perfect match, but don't throw the baby out with the bathwater. Okay, now we're going to get more into this idea of matches. It's hard to find perfect matches for crime, but let me give you an example. Pretend my population was registered voters. Okay, is there a list out there, a sampling frame that's a perfect list of registered voters? Yes. All states keep a voter registration list. Okay, that would be a sampling frame that's a perfect match to that population. What if my population was UH students? Is there a list that perfectly matches that population? Remember, a list is a sampling frame. Yes. If I'm interested in registered students, the University of Hawaii keeps a list of registered students. Not that you could get that list, but there is a list theoretically out there that matches it. One more perfect match. What if I wanted to study, my population was students in the Hawaii public school system, K through 12. There's a list out there of people who are enrolled in the public school system. Of course, since they're minors, you wouldn't be able to get a hold of that list, but the examples that there for that population, there's a perfect match. Maybe a pretty good match. What if my population was homeowners, and I used as a sampling frame phones? Okay, think back before cell phones, but almost everybody who owns a home has a phone in their house. Back when it was just landlines, I think the statistic was something like over 95% of homes in the United States had a phone. Okay. What if I used phones to reach registered voters? Okay. What you can do with phones, by the way, is, and I don't know if they're doing this with cell phones, and I hope not because we pay per minute, but if you've ever gotten a phone call at your house asking you to be in a certain study, what they do is they have something called random digit dialing. And what that is you sort of put in the prefix. For example, in Waianae, the prefix is Waianae Makaha. I believe the prefixes are 695 and 696. And if you wanted to study Makaha, you would have the computer randomly dial the last 4 digits. That way you get both listed and unlisted numbers. So, for example, I'm not listed in the telephone book, but I get these calls because computers actually randomly dial digits on the telephone, and that gives you random selection. So for the population of taxpayers, phones are not a perfect match, a perfect sampling frame, but it's a pretty darn good match. The vast majority of people who pay taxes probably have phones in their homes. Let me give you a bad match. What if my population was poor people? Think of any poor population you could think of, okay? Uninsured women in need of prenatal care. The homeless is a great example. Except with now that they have cell phones, I bet you there's actually people who are homeless who have cell phones, but let's pretend you were thinking of landlines. But even if you were thinking of, cell phones, that's probably a pretty bad match. For homeless people as your population, a good proportion of that population does not have phones. So using a sampling frame of phones to reach homeless people is a bad match. Okay? Let me give you a criminal justice example. This is why it's difficult to study any deviant population. What if I wanted to study car thieves as my population? Okay? And I said, okay, well, I don't have a list of car thieves out there, so what I will use is I will use people who are sitting in jail or prison right now who have been convicted of car theft as my sampling frame. Now that might be a really bad match. Why? Because maybe only the dumb car thieves get caught. A better example is even drug dealers. Okay? Unless you're a street drug dealer, if you're a house drug dealer, really the only way you're going to get caught is if you sell to somebody you don't know, or you sell in the presence of somebody you don't know. So in that case, perhaps it's only really dumb drug dealers that get caught. So if I wanted to study drug dealers and I used only people who are convicted of drug dealing, perhaps and I don't mean this in a bad way, I'm just sort of allowing you to visualize this. Maybe I'm just getting the ones who got caught, and maybe that's not representative of all drug dealers. Maybe they're somewhat a little bit dumb. Okay, now I don't mean that in a bad way, but just to give you an example. Now what if I wanted to study all drug users, all people who use drugs, in this case let's say alcohol, because you can all relate to using alcohol. Now what if that's my population, I wish to study all people who use alcohol. Well, is there a list of all people who use alcohol out there, for example, in the United States? No, there is not. Okay, but let's say, well, what I'll use is I will use a sampling frame of people who are in treatment for alcohol abuse. Okay, so people who are in treatment for alcohol use. Is that a good population of all people who use alcohol? No, it's a bad match, because by definition, only extreme alcohol users, people who use alcohol in an extreme way, extremely problematic use of alcohol, that's in general the only people who end up in treatment. Okay, people who can have a good, I should say a more rational relationship with alcohol don't end up in treatment. So if you were to study just people in alcohol treatment, you would not get the sort of functional users of alcohol, if you will. Okay? So using any treatment population to study any type of drug user, be it alcohol, marijuana, methamphetamine, etc., the problem with that is that you are getting, by definition, the most extreme problematic drug users. Those are the ones who end up in treatment. So that's probably a bad match. Now, don't throw the baby out with the bathwater, because, in a lot of instances, what's your alternative? So there are a lot of drug studies that use treatment populations to study them. As long as you define your population as problematic drug users, or people with heavy drug use patterns, using treatment lists as a sampling frame is not so bad. Okay? But you can see if you wanted to study all drug users and you use just treatment populations, you're going to systematically miss the people who don't use drugs in a really problematic way. Now, what about phones to reach all victims of crime? Remember I said that the U.S. government uses we want to know everybody who's victimized of crime, and we use the household population to approximate everybody in the United States. So it's the U.S. household population aged 12 and older, to approximate all people who are victimized of crime. Now, in a way, the household population aged 12 and older covers the vast majority of people in the United States, okay, who would be victims of crime. Okay, so in that sense, it's pretty good, but it's not perfect. Okay. Why? Well, people who don't live in houses, who are in a transient living situation, think of people living on the beach, or people living on Skid Row. Those sorts of people are, we know by anecdotal evidence, living that sorts of lifestyle exposes you to crime at a greater rate. So people who are not in homes are actually victimized by crime at a higher rate than people who do not live in homes. Just, if you can't conceptualize that just commonsensically, let me give you one example. If I'm living on the beach and I have all of my household population, I'm saying all of my household goods with me, it's much easier for me to get ripped off than if I had a home, because, I mean, if I had all my stuff in a tent, it's much easier to break into a tent than it is to break into a house. So you can see how people in a homeless situation would be easier to victimize. Another example would be, if you look at in Hawaii at this current time, there's a lot of people living on the beach, and their tents are really close together. Now, what if a lot of these people also use alcohol. I drive by them every day. I live out in Makaha. I'm not saying they all do, but a good portion of them. I can imagine that if you're really close to somebody's tent and you got some knucklehead who gets drunk all the time and comes over and pees on your tent, I don't think you're going to call the cops and say, hey, somebody's peeing on my tent, as if somebody was walking onto your property and peeing on your property. You might be, if they did that every night, you might be more tempted to call the cops. Chances are people living on the beach in that situation are going to resolve their differences, perhaps using violence or the threat of violence. So you can see how people living in transient situations are at a greater risk for victimization of crime. So when we use the U.S. household population aged 12 and older to represent everybody who might be victimized by crime in the United States, you can see how that misses a very significant portion of that population. So that's an example of an okay but not perfect match between a sampling frame and a